Thinking big has never been easy. Throughout history, those who challenged conventional wisdom were not only criticized, but they frequently risked their health, safety, and even freedom. But that did not deter their efforts to tackle complex problems and overcome daunting odds. We call them explorers, those who dared to go where others would not go. They pushed the envelope and inspired innovation to solve the greatest challenges of their time. Remember, there was a time when everyone thought the world was flat and you couldn't sail west to go east. Explorers proved you could. People dreamed about walking on the moon. Explorers made it happen. Explorers dared to push the technical limits and venture miles under the sea. In doing so, they changed our understanding about what was possible. ARPA-E embodies this same spirit of exploration for energy, to tackle significant problems and take fresh approaches to existing challenges, to think big, to think bold, and to think differently in order to discover new paths, accelerate technology adoption, and ultimately change the way our country produces, transports, and consumes energy. Since I came to ARPA-E, there are two questions that I get asked repeatedly. I'm sure the first one will come as no surprise to all of you. It's, how do I get funding? But I expect you may not know the second most frequently asked question. How does ARPA-E measure success? At ARPA-E, we believe big ideas are important, but only if they make a difference. I'd like to talk today about 4 areas where I believe we are making a difference: convening great minds, fostering public partnerships, forming new companies, and spurring private investment. The first is convening great minds. At ARPA-E, we believe great minds don't think alike. So we deliberately focus on convening people with different perspectives from different disciplines and institutions to solve some of our nation's most complex energy problems. We believe transformational change can happen if you dare people to think audaciously. We search out new ways of looking at problems and then fund multiple approaches towards the same goal. Let me give you a couple of examples. The first one in our AMPed program. Our early battery programs at ARPA-E taught us that while battery chemistries are crucial, there is also an enormous opportunity to improve battery performance, perhaps 25% or more, through breakthroughs in battery management. Now, battery management is already an active area of research today, but we felt that various communities attacking parts of the problem were not collaborating sufficiently. We also saw exciting developments outside of the traditional battery sector, like advanced sensors. So we asked the various communities to come together and think holistically about system-level solutions incorporating all aspects of battery management, from sensing to power control to real-time management algorithms. We even set up a teaming partner list to allow experts from these different disciplines to discover one another. And it worked. Bringing people together in new ways sparked innovation we never would have imagined. Let me highlight 2 separate projects, one led by PARC and one led by Battelle. For the first, a group of experts at PARC had recently developed low-cost optical fiber sensor systems and had a bold idea. What if you ripped out all the traditional electric sensors in a battery and replaced them with a fiber optic battery management system? In responding to ARPA-E's solicitation, they were able to team with one of the top global battery suppliers and are now being funded to prove out the concept. Meanwhile, on the other side of the country, an engineer at Battelle read our solicitation and walked into his colleague's office with an entirely new approach: to use the battery itself as an optical sensor medium. They quickly assembled a multidisciplinary team: an electrical engineer, a battery materials expert, a physicist, and an optics expert, to brainstorm this self-proclaimed crazy idea. Well, that idea too is now being funded in collaboration with the university under our program. So here we have two distinct innovative projects utilizing optical control technologies for batteries. Some may say this is serendipity, but we think it may be exactly the type of new technology inflection point that changes what's possible. I guess we'll all just have to stay tuned to find out. Let me switch gears to another new project for my second example, one involving natural gas. Just over a year ago, we convened 100 of the world's leading experts in physics, chemistry, and engineering to explore new options for natural gas conversion. The workshop sparked a connection between materials scientists at Cerematech and chemists at UC Berkeley, two groups that had never met and didn't realize they had solutions to each other's challenges. The team at Berkeley had been making great strides on gas-to-liquids catalysis, but were stuck on membrane technology. Only after they partnered with the team at Cerematech working on advanced membranes could they chart a path forward. Now the groups are embarking on a joint program to develop a small-scale membrane reactor to convert natural gas into transportable liquids in one simple process. If successful, this technology could allow efficient use of natural gas in the most remote locations, natural gas that today is simply burned. This originated from a one-day workshop. Again, some might call this serendipity, but at ARPA-E, this is a core part of our strategy. The next three areas where we are making a difference involve handoffs. The greatest discoveries take time, money, and patience. After all, it took Christopher Columbus 3 funded trips to discover the New World. Because we focus exclusively on early-stage R&D, many of our projects will need additional investment to achieve their technical breakthroughs and reach the marketplace. However, when we launch projects, we expect a credible path to additional funding and commercialization. We have a dedicated tech-to-market team that partners with project teams from day one to help them identify the path that is right for them based on their technology and target market. Think of it as market-oriented exploration. The first handoff is through fostering public partnerships. We have a number of projects that have obtained their next stage funding from another government partner. I'd like to highlight one of those. We are all too aware of the human and financial costs of moving fuel to our military bases on the front lines around the world. However, today, there is no good alternative to using diesel generators to run the air conditioning and heating units, like you see here, needed to keep equipment and people functioning in these remote areas. To address this challenge, we recently announced a partnership with the U.S. Navy to advance research in 5 projects from ARPA-E's Beat It program that has been focused on changing what's possible in air conditioning efficiency. Infinia is one of these projects. They are developing an air conditioner and heater in a single unit that uses an unconventional, high-efficiency technology. Their cost-effective design uses a Stirling cycle machine with helium as the working fluid to heat or cool more efficiently than conventional systems. Infinia's improvements to these systems will enable the cost-effective mass production of compact, high-efficiency air conditioners. This partnership with Navy will give Infinia the resources necessary to customize their technology for military applications. If they're successful, they could reduce the amount of fuel used at war zone bases for heating and cooling by up to 50%. These same developments could also be applied to make the heating and cooling systems we use every day more efficient. The second handoff for our technologies is the formation of a new company. Since we began over 4 years ago, we've witnessed technologies invented in university labs launch into new companies in energy storage, biofuels, and efficient thermal devices. The explorers leading these startups believe in the promise of their technology and are taking the initiative to commercialize them. One example involves the challenge of grid-level storage. The capability to store electricity would provide the flexibility and reliability needed to transform the power grid from something that our grandparents would recognize to a modern electrical system capable of dealing with the challenges and complexities of the 21st century. Engineers at City University in New York took up this challenge and recognized the key was to develop a battery chemistry with the right balance of ultra-low cost, long life, and high efficiency. Their approach was to develop a new zinc-manganese battery for storage, inspired by the very low-cost but non-rechargeable flashlight batteries. They re-engineered it to make it rechargeable. At last year's summit, they demonstrated this approach on a lab scale with thousands of cycles of recharging at substantially lower cost than the rechargeable batteries in laptops or even the lead-acid batteries used in cars. Since then, they have formed a new company, Urban Electric Power, right in the heart of Harlem. Their first test is in their own building, where they're running a demonstration system to manage peak power and minimize electric demand charges. If they're successful, their electric storage systems will enable a robust, reliable, and more secure electric grid. Their idea is moving from the lab towards the market across the board. As you know, creating options for transportation fuel is critical. At ARPA-E, we're exploring new possibilities to address this challenge. From thinking about how to make biofuels more easily, to how to power our vehicles with abundant natural gas, to literally inventing new sources, like electrofuels, created through pathways that had never before been considered. We're working on the creation of a diverse portfolio of ways to power America. While most of our fuel technologies are still early in their development, we continue to see signs of progress in new approaches. For example, those at UCLA and the University of Florida. At UCLA, in close partnership with Easel Biotechnologies, they've developed and demonstrated a fully integrated prototype process. Their system integrates electrochemical reduction of carbon dioxide to produce formate that microorganisms can then utilize for the production of biofuels. In addition, we're exploring how to make fuel directly from sunlight via a project at the University of Florida. They have developed reactor technology that converts concentrated solar thermal energy to syngas, which can then be used to produce liquid fuel. They are currently scaling the process to 10 megawatts and have formed a new company, Solar Fuels, which is currently mapping out the funding and the relationships necessary to move this technology forward. The final handoff is spurring private investment from established companies. Many technologies related to energy require significant capital and extensive market reach to be fully deployed. We are proud of the partnerships we have already established with companies that are providing expertise and cost share for our projects. We are now seeing even further engagement to move these projects one step closer to the market. Let me tell you two of those stories. In today's increasingly electrified world, a significant amount of electricity is lost when you have to modify to a different current, voltage, or frequency. Most power converters are based on decades-old technology and rely on expensive, bulky, and failure-prone components. By 2030, about 80% of the electricity used in this country will flow through power converters. This presents a significant opportunity to save energy. At ARPA-E, we've funded a number of technologies to provide solutions to these problems, including one at Virginia Tech. We're finding bold, new solutions for converting electricity between different currents, voltages, and frequencies with minimum energy loss. The Virginia Tech project is establishing a voltage regulator that uses semiconductors made of gallium nitride on silicon and high-frequency soft magnetic materials. These materials can be used to build voltage regulators that are 10 times smaller than those in use today. These advances promise to eliminate the trade-offs product designers must often make between size and efficiency. To date, the project has demonstrated power densities 5 times better than the best that are commercially available today. After proving their technology in the lab at Virginia Tech, the team is now partnering with Empyrean to commercialize the integrated magnetic components. Virginia Tech aims to demonstrate the manufacturability of the new magnetic materials with Empyrean's voltage regulators to enable converters with high efficiency, low noise, exceptional thermal performance, and high reliability. These efforts could lead to a new generation of electrical products, which would increase the efficiency of everything from data center power supplies to smartphones. An additional story involves internal technical development. To expand electric vehicles, we need batteries with significantly lower cost, longer range, and improved reliability than today's battery packs. If we can achieve this, we'd have a real breakthrough. When Applied Materials researchers submitted an application for ARPA-E funding, they were looking to grow beyond semiconductors, displays, and solar. As the world's leading supplier of equipment to the chip-making, flat panel display, and crystalline silicon solar materials industries, what Applied does best is build world-class materials engineering manufacturing equipment. The project they proposed to ARPA-E was the development of radically new equipment that could manufacture batteries faster, cheaper, and with better performance, higher capacity than anything else on the market. A truly bold idea. With the ARPA-E funding, the project has progressed technically to the point that Applied now sees energy storage as a potential strategic business opportunity. And as such, they plan to double down with their own money in order to bring this technology to the market. With ARPA-E's small catalytic funding to overcome the very early stage technology risks, Applied Materials is now positioned to develop a totally new line of business for America. In addition to the partnerships I've highlighted here, We've also seen direct investment into companies we have funded. 17 companies have attracted over $450 million in follow-on funding. This private capital will allow these companies to further their progress and map pathways to the market. Today I've shared with you 4 ways we are making a difference, bringing people together to think bold ideas and solve the greatest energy challenges of our time. I've highlighted just a few of the projects that are gaining speed in moving to the market. But these are just a fraction of the 285 projects we have launched to date at ARPA-E. These are today's explorers, and we are drawn by the boldness of their ideas, inspired by their determination, and encouraged by their progress. Just as past explorers charted their course and set off on their voyages, not knowing what lie ahead, ARPA-E takes bold chances, explores new ways of operating, discovers new partners, and creates communities focused on transformational change. While I'm sure there will be challenges on the horizon, I have no doubt that market-oriented exploration is the answer to securing a bright and prosperous future for America. All great civilizations have focused on exploration to address the challenges of their day and secure their future. We are no different. I am heartened by the strong partnerships and signs of technical progress in both the public and private sectors. Together, we have embarked on a journey to change what's possible, and I am confident that we can do just that. Thank you.